All right, so in this video, I'm going to be talking through the notes on depreciation. So I'm going to cover pages 21, 22, and 23. Um, yeah, and here we're talking about depreciation. So if we read the definition, depreciation is the value that an asset loses over time. So imagine you buy a new gaming computer for $2,000. Because gaming computer technology improves so quickly, your computer will lose half of its value each year. So, how much is your computer worth 1 year later? Well, if we start at 2,000, 1 year later, that would be 1,000. Right, you've lost half of its value immediately. Also think about it as 2,000 times 0.5. 2 years later, we'll lose another half of its value, so we're down to 500. And then a decade later, well, now we have to do that splitting in half 10 times. So what we're going to do, I'm going to start with that 2,000. We want to multiply it by 0.5 10 times. We represent that to the 10th power, right? We want to split it in half 10 times. We go to our graph calculator. We have 2,000 times 0.5 to the 10th power. If we hit enter, we see that it is going to be worth just making sure I typed everything in there correctly. Yeah, it's going to be worth $1.95. I mean, that's not completely unreasonable if you think about decade-old computer. I mean, probably more than $1.95, but maybe not much more. Um, and for this, we're going to use this formula. So we have UN is equal to U naught, our initial value times 1 minus R to the nth power, where N is the number of years and R is the depreciation rate. UN tells us after the value of the thing after N years if it starts at an initial value U0. So let's say at an example over here, a lathe is purchased by a workshop for 250, whatever currency that is. It depreciates by 20% a year. Find the value of the lathe after 3 years. All right, so UN, that's what we're trying to find, right? We want to try and find the value of the lathe after 3 years. U naught is 2,500. R, that's 0.2. And then N here is 3. So we do UN is equal to our initial value, 2,500, times 1 minus our depreciation rate to the third power. And remember here, this 1 minus, because if we're depreciating 25% of the value, then we are retaining, right? The amount of value that's retained from year to year is 80% of its value, or 0.8. So you want to do 2,500 times 0.8 to the third power. 2,500 times 0.8 to the third power. We get 1,280. And so that's going to be the value of the lathe after 3 years. All right, in the summer of 2025, Mr. Ninto bought a car for $22,500. If he expects my car, it's great grammar, if he expects his car to depreciate at a rate of 15% per year, how much will his car be worth by the summer of 2023? So UN, that's what we're trying to find. U naught, that's the initial value of the car, 22,500. R is going to be 0.15. And N, well, if the car was bought in 2025, we're trying to figure out 2023. So that is 8 years later. So then we have UN is equal to 22,500 times 1 minus 0.15 to the third power. That's going to be 22,500 times 0.85 to the third power. So 22,500 times 0.85 to the third power. That is 1,000. $13,870. So $13,870 and $17.81. $17.81. It's gonna be the value of the car after 8 years. All right, and a little trick here, if you are so inclined. Now you have to be a little bit, we're kind of not using the tool in the same way, so you need to be a little careful. But if you are someone who really likes the TMV calculator, you can actually also do this on the TMV calculator. So you would put n equal to 8. So this is the problem from example 3 with a negative interest rate starting at a present value, no payment. And PY and CY are 1 because the depreciation, we're just compounding it at the end of the year. So this is essentially a negative interest rate, right? Like we're earning negative 15% interest on the money that I put into the car. So if you plug in those values, you get this, which we see is matched in the calculator. That's not what I got on the last. All right. So I apologize. I need to go back and revise what I did in the last one because I typed in 3 as the exponent instead of 8, changing our answer to what it should be. All right. I apologize for that. Don't know where the 3 came down from the problem ahead. I am recording this at the end of the school day. I've been teaching for the last 3 hours, so I apologize. That should be 6,131 and 4 cents. All right, cool. All right, so now let's try these ones over here. So Donald bought a new stereo for $458. It depreciates in value by 25% per year. Find its value after 5 years. So that's going to be 458 times 1 minus 0.25 to the 5th power. It's going to be 458 to the 0.75 to the 5th power, or times 0.75 to the 5th power. So if we do 458 times 0.75 to the 5th power, we get $108.69. All right. Farm vehicles are known to depreciate in value by 12% each year. If Susan buys a quad runner for $6,800, how long will it take for the value to reduce to $1,000? So this is one where it might actually be useful to use our TMV calculator. If we go Finance TMV Solver, N is what we're trying to find. Our interest rate here, we can put it in as negative 12. Our present value, well, that's the, 12,000? No, 6,800. So that's the 6,800 initial value, PMT of 0. Future value, we want to figure out when is it going to get to 1,000. So now we want to go alpha, enter. We see that's going to take 15 years. If you want to gut check this, we can do, so let's do 6,800 times 0.88 to the 15th power. You can see that we get very close to 1,000. So you can see that that makes a lot of sense. All right, Greg bought a new snowmobile for $1,400. 3 years later, he sold the snowmobile for a fair market price of $950. What was the annual rate of depreciation for the snowmobile? All right, so for this one, we can use our finance calculator again. Here, N is 3. I is what we're trying to find. It was initially $1,400. No PMT. Future value, you want to figure out when is it going to fall to, or how is it going to fall to 950 over 3 years? What does the interest rate need to be? Well, negative 12.125, meaning that it needs to depreciate at a rate of, so the depreciation rate is 12.1%. Okay, on to page 23. So Hannah buys a car for 24,900. The value of the car depreciates by 16% each year. Find the value of the car after 10 years. All right, so we're going to take our initial value times 0.84 to the 10th power. Remember that 0.84 is 1 minus 0.16, right? So 1 minus 0.16 gives me that common ratio. So if we do 24,900 times 0.84 to the 10th power. Let's just double check that I typed all those in right. 24,984 to the 10th. And I get 4355.04. 4355.04. That's the value of the car after 10 years. Patrick buys a car for $12,000. The car depreciates by a fixed amount each year, and after 6 years, it is worth 6,200. All right, so this is one where I think it's easier to just use the finance calculator. N is 6. We're trying to find the interest rate. The present value is negative 12,000. Payment, nothing. Future value is 6,200. And you could go alpha, enter. We see that the interest rate or the depreciation rate required to make that happen is 10.4%. All right. And then Phil's phone shop sells Azura smartphones for $14.99 and Belson smartphones for $850. It is expected that a Belson smartphone will depreciate at a rate of 20% per year. After 2 years, Azura smartphone is worth $735. So show that the expected annual depreciation rate of Azura is 30%. So what we can do there is we can use our function un is equal to u1 times 1 minus r to the nth power. That means that 735 should equal 1499 times 1 minus 0.7 to the second power, or 1 minus 0.3 to the second power, which is 0.7. And if we do 1499 times 0.7 squared, we do indeed get $735. So this is true. A smartphone, an Azura smartphone and a Belson smartphone will have the same value n years after they were purchased. All right, so we can do this a variety of different ways. So what I'm first going to do is I'm just going to create explicit formulas for the price of an Azura smartphone and a Belson smartphone. After n years. So for Azura, it's going to be un is equal to 1499 times 1 minus r times 1 minus 0.3 to the nth power. It's going to be 1499 times 0.7 to the nth power. For Belson, it's going to be 850 times 1 minus 0.2 to the nth, which is going to be 850 times 0.8 to the nth. Now what I'm going to do is I'm going to put both of those into my calculator. So I'm going to say 1499 times 0.7 to the x for y1. I'm going to say 850 times 0.8 to the x in y2. And I'm actually going to use this. I'm going to use the table function here. So if we go to the table function, we can see the price of each after each year. So in y1, we start with, or in when x is 0, the Belson is 1499, or the Azura is 1499, the Belson is 850. After 1 year, 1049 and 680. After 2 years, after 3 years, and we can see that they cross paths during the 3rd year, so before the end of the 3rd year. So if we want to find the exact value of n, this is where we can do the intersection. So we can go window, x max, x min, that's fine, but let's change our y max to be 1500. And then we can go graph, second, trace, intersect, there, and there. See that the intersection yep, it's 4.24 and equals 4.24. All right. Comment on the validity. Ask me about this in class. I'm going to talk to you guys about it.